Okay, so following some a little bit more difficult examples, let's look at a little bit more straightforward piece. So for this practice problem, we want to write a rational function with the following characteristics. We have no real roots. Our y-intercept is at 0, -4. Our vertical asymptote is at x equals 1, and our horizontal asymptote is y equals 0. So let's take what each of those is telling us. If our horizontal asymptote is y equals 0, that means I need to have something where the denominator has a larger power than the numerator, right? I don't necessarily know what the power will be, but the power of the denominator will be larger than the power of the numerator. So if I had x squared in the numerator, then I would need to have an x cubed as an example in the denominator, so that power is larger. Vertical asymptote of x equals 1, that means I need to end up with x minus 1 in the denominator, right? That means that the denominator has to have x minus 1 in it, so I can have a vertical asymptote of x equals 1. Okay? Then if my y-intercept needs to be 0, -4, that means that my function has to be equal to -4 when x is equal to 0. So for example, if I had x minus 4 in the numerator, then I would have in the denominator -1 if x was 0, in the numerator -4 if x is 0. That ratio is positive 4, but it needs to be -4, so then maybe I could have x plus 4 here in the numerator. Okay, but notice that if that was the case, I would not meet my horizontal asymptote of y equals 0. And y equals 0 is the horizontal asymptote, which means that maybe it would need to have a higher power over here, x squared minus 1. Right? However, if I then come over here and I see I have no real roots, that means I can't cross the x-axis, which means my numerator can't be equal to 0. So well, the simplest thing that we'll do over here is come over here and say, hey, let me take the 4 away, and now I'll have no real roots because the numerator is never equal to 0. The denominator has a larger power, so I'll have a horizontal asymptote of y equals 0. My y-intercept is 0 because the numerator is 4 and the denominator would be -1 when x is equal to 0. And the vertical asymptote, well, I happen to have two vertical asymptotes. It doesn't restrict it. It would be the case that I would have it. And so I will write my rational function as y is equal to 4 over x squared minus 1, right? And then explain why the rational function meets the characteristics required, right? That is the sort of thing that we need to be sure that we can do. We've already explained it, but let's go ahead and type it out, right? Numerator never 0, right? Therefore, or we'll say numerator never 0, so that implies no real roots, right? If x is equal to 0, right, y equals -4, right? So that implies that our y-intercept is 0, -4, right? Additionally, we know that the denominator is equal to 0 at x equals 1 and x equals -1, right? So therefore, x equals 1 is a vertical asymptote. Okay, and for this last piece, we have that the degree of the numerator is less than degree of the denominator, right? That means that my horizontal asymptote is y equals 0. So we've met all of those conditions. Important to understand those pieces. Okay. For our next part, we want to write the equation of each asymptote for the graphs shown. So we have a horizontal asymptote and our vertical asymptote. So we can come in here and we can kind of have a look at what we see, and it looks to be that we have a vertical asymptote of x is equal to 1. Over here, it looks to be that we have vertical asymptote at x is equal to -1, right, as well as x is equal to 2. And for this one, it's a little tougher to see, but it looks to be halfway between 2 and 4. So our vertical asymptotes would be at x is +3 as well as at x is -3. Okay. Horizontally, it looks such that my left and right end behaviors are approaching y equals 2, so y equals 2. Here, a little tougher to see, but on the right side and on the left side happens to be the same, which looks to be about right there, halfway between -2 and -4, so y is -3. Okay. The horizontal asymptote for this one, if I look, it looks to be down here. What am I approaching? And so that horizontal asymptote appears to be y equals 2. Right? Now, I want to make the case very clearly here. The horizontal asymptote is what my function does at their end behaviors if it's horizontal, right? So on the right side, my graph seems to be flattening out and approaching this value of 2. On the left side appears to be flattening out and approaching a value of y equals 2, right? In the middle, I'm equal to 2, and that's okay. That's still my horizontal asymptote. Same thing for this one right here. Horizontal asymptote y equals -3, but my function does equal to -3. It's just what my function is approaching as x goes to +infinity and as x goes to -infinity. If I just have a simple rational function that's a transformation of the reciprocal function, then it is the case that my horizontal asymptote is excluded from the range. Not necessarily the case for more complex rational functions. Okay, so hopefully that makes sense in terms of understanding our characteristics and understanding our asymptotes. If we can understand those details, it'll make our work a lot simpler for graphing rational functions.